In this video, we're going to look to write polynomial functions using conjugates. And to do that, we're going to use the concept of conjugate root theorems. So let's look at these two bullet points. We have P be a polynomial function with rational coefficients and let A and B be real numbers. Main thing we want to look at here is that if A plus radical B is a root, then A minus radical B also has to be a root. And in the second bullet point, let P be a polynomial function with real coefficients and let A and B be real numbers, pretty much the same as the first one. Then if A plus BI is a root, then A minus BI must also be a root. So it's just good to know that if one of those is a root, the other has to be. So let's put that into practice using example 5, part A. So what is a quadratic function P with the rational coefficients in standard form such that P of x equals 0 has 2 plus 5i as a root? So first thing, quadratic function. All right, quadratic tells me that I should have two zeros, and my final answer should have an x squared as its highest degree. And then 2 plus 5i, so since 2 plus 5i is a root, based on the conjugate root theorem, 2 minus 5i is a root. All right, so we need the conjugates of those. So let's look at P of x, and let's figure out what this quadratic function is going to look like. Keep in mind, let's say we had 0 of 5. When you're plugging that in, remember that would be x minus 5. And if you had something like negative 3, remember that would turn out to be x plus 3 when we're writing it within our function. So when we're writing these, we want to do x minus each root, in this case 2 plus 5i, which is this one here. And then we also have x minus 2 minus 5i, which is this one right here. Cleaning up those parentheses, I get x minus 2 minus 5i. Let's get rid of the parentheses within the parentheses, and x minus 2 plus 5i. Okay, so this is now going to simplify to that, and that would be there. I now need to distribute or multiply these. There is the possibility that you could use the difference of squares, but a lot of times that can get kind of confusing. We kind of forget that we could potentially use it. So I'm just going to distribute and multiply everything out. All right, so I have a 3 by 3, so I'm going to make a 3 by 3 Punnett square. And up top, I'll have my x minus 2i, sorry, x minus 2 minus 5i. So that's for these. And then, or x minus 2 and a positive 5i. And those three came from our second group or our second term. So multiplying x squared, negative 2x, negative 5ix, negative 2x, positive 4, 10i, positive 5ix, negative 10i, and negative 25i squared. Now, I want to make a little note of that. Be careful with that I squared. We'll simplify that in just a minute. Looking through my chart, all right, I see that I have a negative 10i and a positive 10i. So before I do anything else, I'm going to cancel those out so I don't waste my time. And the same thing with the 5ix and the negative 5ix. What you'll find with these problems is that at the end, you should never have a radical or a I in your final answer. So you'll see that those will be eliminated. So let's bring our terms over. We have the x squared. Then I have, this minus 2x and minus 2x. So let's combine those. Get minus 4x. I'm going to bring that 4 over. And I'm going to bring this negative 25 I squared. And as you get better at this, you're going to kind of take a shortcut here. So let's fix that. Hopefully you remember that I squared is equal to negative 1. So this becomes x squared minus 4x plus 4 minus 25 times negative 1, which would then become plus 4 plus 25, because we have that negative 25 times negative 1. And then we can combine those like terms and get x squared minus 4x plus 29. Remember we mentioned that we should have a quadratic that has x squared value. Now, it might be like 3x squared or something like that, but it has an x squared. Your highest degree should be an x squared. Just remember that. All right, anytime there's a quadratic, x squared, highest power. If you wound up with an x cubed or x to the fourth for a quadratic, something went wrong. And that's it. So what you really want to key in on here, let me go back to this, let me highlight this real quick, is that the conjugate root theorem tells us if I have 2 plus 5i, I have to have 2 minus 5i. And then just be careful plugging those zeros in, very careful with your signs, and then gradually work your way through the multiplication problem, the distribution, and combining like terms, and you'll ultimately get your final answer. I'm going to do part B in a separate video, so just look for the next one, and it'll be part B will be solved there.